Hello students, welcome to lecture 8 of online chemistry classes. In last class we were solving this question regarding the percentage abundance of C12 and C13, but due to some technical mistake that was incomplete. The question already you have written. They are asked to calculate the percentage abundance of C12. And there are two isotopes of carbon present in mixture, C12 and C13. We assume that abundance of carbon 12 is X, so C13 will be 100 minus X, because together they are present as 100. So this is percentage abundance divided by 100 multiplied by isotopic mass plus we have to sum all, and that equals to the atomic mass, which is given 12.011 given in the question. Then this 12x by 100, 13 into 100 is 1300 minus 13x by 100 is equal to 12.011. 1300 minus 13x plus 12x is minus x, and this 100 will transfer here. So it is 1201.1. So x is equal to, if we transfer it to other side, 1300 minus 1200 and 1.1. If we subtract 1201 from 1300, we get 98.9, which is the value of x, and which happens to be the abundance of C12. That is 98.9. What is C13? 100 minus 98.9. So these were two questions we have solved regarding the isotopic masses and how atomic masses become fractions. But before that, we have defined atomic mass, molecular mass. Atomic mass, we said, is a number which indicates how many times the mass of one atom of element is heavier than 1/12th part of mass of one atom of C12. Lengthy definition, but we have seen what it means. Similarly, we have defined molecular mass also, and now we know these two terms. Molecular mass also we have defined as sum of atomic masses which are present in a molecule. Now we'll go ahead in these two concepts we build up now. And the next concept which we have to learn today is called as gram atomic mass and gram molecular mass. So again we'll just build up these two concepts simultaneously, since atom and molecule, atomic mass, molecular mass, and now we have gram atomic mass and gram molecular mass. See what these concepts are. They are also equally important. Gram atomic mass, which is called as GAM. Gram atomic mass is abbreviated as GAM, or gram atom. Now what we mean by gram atomic mass? A very simple concept. It is nothing but atomic mass expressed in grams. For example, atomic mass of oxygen is, yesterday we have seen, 16 AMU, whereas gram atomic mass of oxygen is nothing but oxygen atom we are talking about, is nothing but 16 gram. So same number we have taken, and this AMU is, we are writing it as gram, and when we do that, it is nothing but atomic mass expressed in a gram, and that is called as gram atomic mass, also abbreviated as GAM or called as gram atom. Means 1 gram atom is gram atomic mass in that. So gram atomic mass is nothing but atomic mass expressed in a gram. Now why this concept is important? We can say next point that gram atomic mass, I will write it as short form GAM, of every element. See this very important statement. Every element, it contains same number of atoms, and this number is called Avogadro's number. Avogadro's number, and it is written as Na equals to 6.022 into 10 raised to 23. For example, if question is asked, how many oxygen atoms are present in 16 gram? We should say that as 16 gram is gram atomic mass of oxygen atom, it must contain 6.022 into 10 raised to 23 atoms, because gram atomic mass of every element contains same number of atoms, means atoms, and this number is called as the Avogadro number. See the next point also. I will go on writing these points. You have to identify the different concepts involved with it. If we say the actual mass of one atom of oxygen, actual mass of one atom of oxygen is nothing but atomic mass in AMU multiplied by this 1.66 into 10 raised to minus 24 gram. Yesterday we have seen that. Now we'll say mass of this many number of atoms, 6.022 into 10 raised to 23 atoms of oxygen is equal to, for one atom we have 16 into 1.66 into 10 raised to minus 24, and for Avogadro number of atoms we have to multiply by Avogadro, and that happens to be 16 gram, because 1.66 into 10 raised to minus 24 multiplied by 6.022 into 10 raised to 23, this appears to be 1, and that 16 gram will remain as it is. So 16 gram is gram atomic mass, as well as it is the mass of Avogadro number of atoms of an element. So these 3 points are very important. So we can define gram atomic mass now. In one more way, we can say it is the mass in gram of 6.022 into 10 raised to 23 atoms of any element. In this way also we can define it. And one last formula we can say, number of gram atoms is equal to mass of element in gram divided by gram atomic mass. We use this formula in calculation. Number of gram atoms of element is equal to mass of element in a gram divided by gram atomic mass, which is again in a gram only. So these 4 very important points in gram atomic mass. The first one is that it is atomic mass expressed in a gram. For example, atomic mass of oxygen is 16 AU, and that's why gram atomic mass of oxygen atom is 16 gram. gram atomic mass of every element contains same number of atoms, and that number is nothing but Avogadro number, 6.022 into 10 to 23. Actual mass of one atom of oxygen is 16 into 1.66 into 10 to minus 24 gram. That's why mass of 6.022 into 10 to 23 atoms of oxygen is equal to 16 multiplied by 1.66 into 10 to minus 24 is for one atom, multiplied by Avogadro number of atoms. That happens to be 16 gram. So you can say gram atomic mass is nothing but mass in gram of Avogadro number of atoms of any element, not only oxygen. It is applicable to any element. The number of gram atoms is equal to mass of element in gram and gram atomic mass. The same concept we can apply to the gram molecular mass, also called as gram molecule. Of course, we need to make some changes here. I will make that changes. If you are writing these points, you just pause this video and write these points, because the same thing I am going to change now. Gram atomic mass I will change here as gram molecular mass, because we know that wording is same. So this is nothing but GM now, and instead of gram atom it is gram molecule. So it is nothing but molecular mass expressed in a gram, and we can say molecular mass of oxygen molecule is equal to how much it is? It is not 16. Diatomic molecule, it is 32 AMU, and that's why gram molecular mass of oxygen molecule is equal to 32 gram. I hope you are understanding this. I am just changing this word here only because it is just atom for element and molecule for substance. Substance is nothing but element or compound. So gram molecular mass of every substance instead of element, we have to generalize it now. Substance contains same number of, I will write here as molecules, and this number is called as, again same, Avogadro number. Na equals to 6.022 into 10 to 23. Actual mass of one molecule of oxygen is, instead of 16, 32 into 1.66 into 10 to 24 gram. Mass of 6.022 into 10 to 23 molecules of oxygen is equal to, again I will make here as 32 into 1.66 into 10 to minus 24 into 6.022 into 10 to 23, and this happens to be 32 gram. That's why I can say mass in gram of 6.022 into 10 to 23 molecules of any instead of element, I will write substance, and number of gram molecules is equal to mass of substance in gram divided by gram molecular mass. So there is no need to get confused. Atoms and molecules already we have distinguished. Atomic mass, molecular mass already we have distinguished, and now we are distinguishing gram atomic mass and gram molecular mass. So it is nothing but gram atomic mass is nothing but atomic mass expressed in gram. Gram molecular mass is nothing but molecular mass expressed in gram. And these 3-4 points additionally we have written to explain this concept. I hope that you understood this concept. There should not be any confusion. Again and again I am stressing this. If any confusion is there, it should be removed as early as possible. Now we'll go ahead and we'll use this formula. Gram atoms, number of gram atoms is equal to mass of element in gram divided by gram atomic mass, and number of gram molecules is equal to mass of substance in gram divided by gram molecular mass, so that our understanding of this concept will be more clear. That is the only way to learn the chemistry. Understand the concept and solve the numericals. Many numericals are to be solved so that all concept will be clear to you. I hope that you are writing these numericals with the answers and you are doing your homework also sincerely. So only 3-4 questions we are going to solve because it's not that much difficult concept here. The question is calculate the mass of 2.5 gram atoms of oxygen. So whenever we come across this word gram atoms, we write the formula: number of gram atoms is equal to mass of oxygen in gram divided by gram atomic mass. We have not written gram molecular mass because they said atoms. If they said molecules, gram molecular mass would have written. And they said calculate the mass of 1.5 gram atoms. So gram atoms formula we are applying. Gram atoms, gram atomic mass, gram molecular mass. In that way we have used this problem. They ask us to calculate the mass of atoms. We can write as mass of oxygen, of course in gram, is equal to number of gram atoms multiplied by gram atomic mass. Number of gram atoms we have given 2.5 and gram atomic mass is 16. 16 into 2 is 32 and 8 is 40. So we can say 40 gram is our answer here. Right. So this is about the gram atoms of oxygen. Now the next one is next question. I write here. You write this question and try to solve it. Calculate the gram atoms. Calculate the gram atoms in 2.3 gram of sodium. So you can say that number of gram atoms is equal to, they ask us to calculate that only, is equal to mass of sodium, in gram divided by gram atomic mass. mass of sodium in gram is given 2.3 and gram atomic mass is 23, and that's why it is 0.1 gram atom. This should be our answer here. Very simple, only one formula we are using. Number of gram atoms is equal to mass of an element divided by gram atomic mass. See the next one now. Calculate the mass of calculate the mass of mass of 1.5 gram molecules. 1.5 gram molecules of sulfuric acid. Calculate the mass of 1.5 gram molecules of sulfuric acid. We can use the formula number of gram molecules is equal to mass of substance, it may be element or compound, in gram, divided by gram molecular mass. Mass of, here is in case of substance, is sulfuric acid. Mass of sulfuric acid is equal to number of gram molecule multiplied by gram molecular mass. I will just change this gram molecular mass to other side. Number of gram molecule is 1.5 multiplied by gram molecular mass of sulfuric acid. H2SO4. There are 2 hydrogens, 1 sulfur and 4 oxygens. It is 2 plus 32 plus 64. 4 to 6 plus 2 8, and this is 98. So 1.5 into 98 is 147 gram. This is our answer here. Not difficult questions these are, but they are different technically. Gram atoms and gram molecules, these words, we should be comfortable into that. So the next one. Calculate the actual mass of 1 molecule of carbon dioxide, which is nothing but CO2, carbon dioxide. We can write the formula. Actual mass of 1 molecule is equal to 1 molecule of CO2, we can write, is equal to molecular mass of CO2 in AMU, atomic mass unit, multiplied by this number, which is nothing but value of 1 AMU. There is 1 carbon and there is 2 oxygens. 1 carbon is 12 Two options is 16. 12 plus 32. 44. Multiply by 1.66 into 10 raised to minus 24. And that happens to be 7.304 multiplied by 10 raised to minus 23 gram. These simple calculations you can do with calculator. Unnecessary again I will not do and waste our time, isn't it? Because you just confirm whether it is correct or not. If it is wrong, then if it is you are not getting the same answer, then just report me and I will explain. If calculations are difficult, definitely I will do with you. But simple calculations, again and again, will not waste time into that, because 44 into 1.66 into 10 raised to minus 24, at least first 44 into 1.66 you can do with calculator and then multiply to 10 raised to minus 24. One last question will do, because all problems will be covered. Calculate the, or just I will write this question for homework. Calculate the number of gram atoms in 1.4 gram of nitrogen. Gram atomic mass of nitrogen is 14 gram. That I have written in the bracket. Number of gram atoms is equal to mass of element in gram divided by gram atomic mass. You can do it within one step. You will get that answer. Right, so this question is for homework. These 4-5 questions are enough to distinguish between, see which term we are using. Atomic mass, actual mass of one atom of element. Molecular mass, actual mass of one molecule of substance. Gram atomic mass, gram atomic mass. Number of gram atoms, number of gram molecules. These are the words we are using and what they mean, how to use them in numerical question. That is the only thing which you should know. I hope that you are understanding this, but with more and more practice, you will understand that you will do in due course of time. Now, we will go ahead in the theory part. Again, one of the important concepts in theory we have to learn. For that, what we are learning now is the Avogadro's hypothesis. Avogadro's hypothesis. Now, why it is important? Because on the basis of Avogadro's hypothesis, one of the important central concepts of this topic, mole, is to be understood here. Mole word we are used as SI unit of amount of substance. How it is related with the Avogadro number, and how it is related to atoms and molecules, that we are going to learn now. So for that we need to learn Avogadro's hypothesis and how this hypothesis has been developed. It started with the Dalton theory. What Dalton has suggested is that elements react with each other in simple ratio of their atoms. One of the postulate of it, Dalton's theory, we said elements, when they react with one another chemical change, they do so in a simple ratio of their atoms. For example, H2O, 2 atoms of hydrogen, 1 atom of oxygen. CO2, 1 atom of carbon and 2 atoms of oxygen. There was one scientist named Gay-Lussac. He just correlated this combination of elements to form a compound atom. That is word compound atom to gases. And he said that gases react means they combine with each other in simple ratio of their volumes. So when elements react, their atoms are in a simple ratio, and when gases react, their volumes are in simple ratio. It's proposed by Gay-Lussac. There was another scientist, Berzelius, and he just combined these two statements, and he said that under the similar conditions of temperature and pressure, equal volume of all gases contains equal number of atoms. What Berzelius said, as elements are combining in simple ratio of atoms, gases are combining in simple ratio of volume, their atoms and their volumes can be correlated by this. Under the similar conditions of temperature and pressure, if temperature and pressure kept constant, equal volume of all gases contains equal number of atoms, because that is the ultimate outcome of these two statements. When we combine these two statements, this statement is bound to the result of that, and that's how Berzelius has been proposed. Then they thought about this simple reaction. H2 plus Cl2 gives 2 HCl, and they said this is 1, 1 and 2, the ratio of their volume. So it is 1 volume, this is 1 volume, and this is 2 volume. As volume is 1, it contains n atoms. This is also 1 volume, so it also contains n atoms, because equal volume contains equal number of atoms, and this is 2 times, so this is called as compound atom, because this is combination of hydrogen and fluorine, 2 compound atoms, or 2n compound atoms, because it is 2 times. This is 1 volume n atoms, 2 volume 2n atoms. We divide this by n. We divide this by n. And what we get now? 1 by 1 cancels, so it is 1 atom. This is 1 atom. And this is 2 compound atom. If we want to have 1 compound atom, divided by 2, it will be half atom, and divided by 2, it is half atom. So what is the meaning of this? Meaning is 1 compound atom is formed of HCl by combination of half atom of chlorine and half atom of hydrogen. But this concept of half atom is against the Dalton's theory. because the atom could not imagine that atom becomes half and it reacts and it forms one component. The ultimate result is Berzelius hypothesis is discarded. Discarded means disproved. They said we won't accept this because if we accept this, it applied to the reaction. It means half atoms are combined. So there is a lot of confusion into this. Avogadro has solved this very important question, isn't it? Because reactions are bound to happen, and if we go on assuming half atom, this is not the correct way to explain the things which we know. So Avogadro comes with the answer with some modification into Berzelius hypothesis. See what modification he has done. We call now Avogadro's hypothesis. What modification he has done? Same words used. Under the similar conditions of temperature and pressure, equal volume of all gases contains equal number of molecules. Instead of atoms, he used word molecules. That's why credit to devise this word molecule goes to the Avogadro. When the hypothesis has been changed to this word molecule, this question has been solved. How this question has been solved? H2 plus Cl2 gives 2 HCl, one volume, 2 volume. Then instead of atoms now, we write molecules, because he said the molecules are being combined here. So see here how this problem has been solved and how it is explained, the all observable properties. So it is nothing but n molecules, because volume is 1, this is also 1, so it is n molecules, and this is 2 volume, so it is 2n molecules, divided by 1, and that's why it is 1 molecule, and this is 2 molecule. And when it is 1 molecule, this is half molecule. Molecule can be half, there is no difficulty in it. Half molecule. But what do we mean by half molecule? If we make half of H2, 1 hydrogen remains. And to what we call it as 1 hydrogen? Hydrogen atom. So half molecule is nothing but 1 atom. 1 atom. That results into 1 molecule. So this problem has been solved by shifting our focus from number of atoms to the equal number of atoms to the equal number of molecules. So Avogadro's hypothesis is very important in explaining the combination of gases. Now what is the conclusion of this? The conclusion is that one molecule splits into atom and they combine. They form one molecule. Molecule can split. It can become half molecule. But atom cannot become half atom and combine. That's why we discarded it. Berzelius hypothesis was completely discarded. It was not approved. But this molecule, this concept is accepted. Because half molecule is nothing but one atom. Because hydrogen is diatomic molecule. Fluorine is diatomic molecule. One molecule contains 2 atoms. One molecule contains 2 atoms. And that's why half molecule can contain 1 atom. That is absolutely okay with the chemical combination. So these 4 sentences, particularly the last sentence, Avogadro's hypothesis, under the similar conditions of pressure and temperature, equal volume of all gases contains equal number of molecules. So this very important concept. We'll use this in calculation of the mole concept in the next class. So in this class we will learn about GAM, GAM, number of gram atoms, number of gram molecules, their meaning, their formula. We use that formula and we learn about the Avogadro's hypothesis. Revise it, read again and again. Try to write these statements without looking into notes or textbook, because when I explain it, it appears to be simple, but they are not. In examination only you will come to know that how much practice is needed to write that question in a proper manner. Just like on the bike in the mirror is written, objects are nearer than there seems to be, like that. So this becomes, you feel it easier, but it is not easy. So when you practice it, then only you will come to know what are the meanings of it. So keep studying. There is no other alternative way without hard work. So do that. Thank you for watching this video.